You know, it feels like just yesterday we were all trying to figure out what ChatGPT even was, and now
Right.
the speed at which these large language models are evolving is just breathtaking. It can be tough to cut through the noise, to understand what's truly significant.
It absolutely can. The
Mm.
sheer volume of new models, new capabilities being announced, it can leave even people following the field pretty closely feeling a bit lost sometimes.
Yeah, that's kind of where we come in. Welcome to the deep dive.
Hmm.
We take a dense stack of info in this case, a really comprehensive look at the latest AI developments, and we try to distill it down, get to the essential insights.
Like a shortcut.
Exactly. Your rapid knowledge delivery system, bringing you the key understandings, maybe a few surprises along the way.
Hmm?
And today's deep dive is really crafted for you, someone who wants to grasp these advancements quickly, but, thoroughly, who appreciates seeing different angles on a complex topic.
And enjoys those aha moments.
Right, without feeling overloaded by just raw data.
So our goal today is pretty laser focused. We're diving into the recent progress in these generative LLMs.
Hitting under the hood.
Yeah, really getting under the hood to compare some of the newest models, explore the exciting possibilities they unlock, all based on this in-depth report we've been digging into.
Exactly. We've got this detailed report, really maps out the current AI landscape. So let's get right to it.
Okay.
When we look at these generative LLMs right now, what's the headline? What's the most important thing to understand, sort of big picture?
Well, the biggest story is probably the remarkable strides these models have made in generating text that sounds, well, human quality text.
Right.
But it's much bigger than just writing now. These LLMs are becoming these really versatile tools across, tons of industries,
Mm.
fundamentally changing how we interact with technology, how we approach different tasks.
So the report highlights a really detailed examination of the newest models. What's the core reason for taking that closer look? What are we trying to figure out?
The main aim here, really, is to understand the current state of the art.
Oh.
We want to identify what these cutting-edge models are truly capable of, where their limitations still lie,
Uh-huh.
and importantly, how they stack up against each other. By understanding their individual strengths, their weaknesses, we get a much clearer picture of where this tech is heading.
Right. Makes sense. And the report introduces a lineup of the key players: GPT-4o, GPT 4.5, Gemini Ultra, Gemini 2.5 Pro, and then Llama 4 Scout and Maverick.
Yep, that's the current roster of heavy hitters.
That's quite a list. Let's maybe tackle them one at a time, focus on their core functionality and why that's relevant for someone trying to get a handle on this field. Let's kick off with GPT-4o. What's the essential info there?
Okay, GPT-4o from OpenAI. This one's a really significant step, particularly because of that O. It stands for Omni.
Omni.
Yeah, think of it like unifying different senses for the AI. It's a major advance in what we call multimodal AI.
Multimodal. Okay, so multiple types of data.
Exactly. It can process and understand text, audio, images, and video as inputs,
Wow, all of those.
all as input. And then it can generate text, images, and audio as outputs. And the key thing is it does this all within a single integrated model.
Okay, so instead of having separate AIs for speech to text, then text analysis, then text to speech.
Well, like a pipeline.
Yeah, GPT-4o just handles it all together.
Precisely. This integrated architecture, compared to those older pipeline methods, leads to significantly faster response times.
Faster is good.
Faster is definitely good, but maybe more importantly, it lets the AI get a much richer understanding of the context. Things like tone of voice, even implied emotions.
That sounds like a potential game changer for things like, I don't know, virtual assistants or just talking to computers generally.
Definitely.
The report also mentions a 128,000 token context window. In practical terms, what does that let the AI do?
Think of the context window as the AI's short-term memory, basically. How much information can keep track of at once. So 128,000 tokens is pretty substantial. It means GPT-4o can hold onto and refer back to a much larger chunk of information during a conversation or when it's processing a document.
So it can follow longer conversations, understand more complex documents.
Exactly. It can remember and understand longer, more complex stuff without losing the thread.
Got it. And the fact that it's reportedly faster and more cost-effective through its API compared to the older GPT-4, that's definitely a win for developers, right?
Absolutely. Big win. And what's particularly interesting, the report notes, is its apparently superior performance in languages other than English.
Oh, interesting.
Yeah, and also in tasks that need it to understand vision and audio together. That really broadens its potential reach
Right.
globally.
And there's a smaller version, too, GPT-4o Mini.
Right. Yeah, the report mentions that briefly. Initially just text and image support, but with plans for audio and video later. So kind of a more accessible version focusing on those core multimodal bits.
Okay. Now, let's move on to GPT 4.5. OpenAI is apparently calling it their biggest and best model for chat. What's the key thing here? What's different?
Well, unlike some models that really push the reasoning side, GPT 4.5 seems to be focusing heavily on unsupervised learning.
Unsupervised learning, remind me.
It's basically the AI learning from raw data without humans explicitly telling it what's what, without labels.
Okay.
So this approach lets GPT 4.5 build up a really, really broad knowledge base and get much better at spouting complex patterns in data on its own.
So it's like learning by just observing massive amounts of information. That sounds incredibly powerful for, say, finding trends in huge data sets or something.
Exactly, that's the idea. It shares that same large 128K token context window as 4.0, and it can also handle text and images as input.
Right.
The report suggests a release around February 2025 and notes its API costs are likely going to be higher than GPT-4o.
Higher cost, okay.
Yep.
Expected maybe for the biggest and best.
Probably. But what's really got people talking is the speculation around its parameter count, potentially around 12.8 trillion.
Wait, trillion with a T.
Trillion with the T, which, if true, is just orders of magnitude larger than most previous models, suggests a potentially massive jump in complexity and capability.
Wow. 12.8 trillion parameters. That's hard to even wrap your head around. Okay, let's switch gears. Google's offerings. Gemini Ultra and Gemini 2.5 Pro. What's the story there?
So Google's been tackling multimodal AI with their Gemini family. Gemini Ultra version 1.0, that was their initial big launch model.
Right, remember that.
It had a 32,768 token context window, smaller than the OpenAI ones we just discussed, but really solid support for lots of input types. Text, images, audio, video, even code. And it was notable because at launch, it actually beat GPT-4 on some key benchmarks.
Okay, so Google came out strong. Now, Gemini 2.5 Pro experimental, that's positioned as their latest and greatest. The report calls it a thinking model.
That's right. Gemini 2.5 Pro is presented as Google's most capable AI currently. Strong emphasis on its ability to reason through complex problems, generate well-thought-out responses, particularly good at programming tasks, too.
And the context window.
This is where it gets wild. A million token context window.
A million.
A million. And Google's even talked about plans to potentially double that to 2 million down the road.
Okay, a million tokens. What kind of doors does that open up? What becomes possible?
Imagine feeding it like entire novels or massive stacks of research papers, complete software code bases, and having the AI actually understand the connections and the context across the entirety of that information dump.
Wow.
The report mentions it can take all sorts of inputs, text, images, audio, video, even whole code repositories, although its output right now is mainly text.
Still, that input flexibility is huge.
Yeah, and it's been ranking top in the L Arena benchmark, showing really strong performance in programming, math, logic, and crucially processing those super long contexts.
So for tasks involving analysis of truly enormous amounts of information, Gemini 2.5 Pro sounds like it could be, well, revolutionary.
It certainly has that potential.
Okay, now let's turn to Meta. Llama 4 Scout and Maverick, described as their first native multimodal open weight models. Lots of terms there. What does open weight mean here?
Open weight basically means Meta releases the model's parameters, the weights that store its learned knowledge publicly.
Okay.
So while it might not be fully open source like the training code itself, researchers and devs can take these weights, use the model, study it, build on top of it, fine-tune it for their own specific needs.
Got it. So more accessible than closed models like GPT. And they use a mixture of experts architecture. What's the benefit of that?
Mixture of experts, or MOE. The idea is the model isn't one giant network, but it's made up of many smaller, specialized subnetworks, the experts. For any given task or input, only some of these experts get activated. So you can have a model with a huge total number of parameters giving it lots of capacity, but it stays computationally efficient because you're not running the whole massive thing every single time.
Interesting. Sort of like having specialists on call.
Pretty much, yeah.
So Llama 4 Scout, the report says 17 billion active parameters out of 109 billion total across 16 experts.
That's right.
And an industry-leading 10 million token context window. That's even bigger than Gemini 2.5 Pro's current window.
It is. 10 million tokens is enormous.
What on earth could you analyze with that much context?
Think about analyzing the entire history of a huge software project in one go. understanding how ideas evolved, how different parts of a massive code base relate,
Wow.
all within that single processing window. And it's natively multimodal, handles text, image, video inputs from the get-go using something called early fusion.
Okay. And then Llama 4 Maverick. Also 17 billion active parameters, but out of a 400 billion total,
Yeah.
128 experts.
Yep, Maverick scales up the number of experts significantly.
And it has a still very large 1 million token context window, handles text and image input, and apparently outperforms GPT-4o and Gemini 2.0 Flash on some benchmarks.
That's what the benchmarks suggest, yeah.
Yeah.
Even rivals DeepSeek v3.1 for programming and reasoning tasks. So very competitive performance.
That's a seriously impressive set of models from Meta.
It truly is. Each one of these models we've discussed, from OpenAI, Google, Meta, they represent the cutting edge, and each brings unique strengths to the table.
This is a lot to absorb. The report does include a table, right, summarizing the key specs. Maybe we can just quickly hit the highlights from that to make the comparisons a bit clearer.
Absolutely. Yeah, the table is super helpful. It lays out the developer, the estimated parameters where we know them, anyway, the context window size, multimodal inputs and outputs, knowledge cutoff dates, and those key strengths the report emphasizes.
Okay, so just to quickly recap some of those key strengths again. GPT-4o, it's really about that seamless multimodality, speed, API cost-effectiveness, and non-English performance. GPT 4.5, big focus on that broad knowledge base from unsupervised learning, pattern recognition. Gemini Ultra, solid all-around performance, good multimodal support.
Yep.
Gemini 2.5 Pro, the one for advanced reasoning, programming, and those really long contexts.
The thinking model with the million tokens.
Exactly.
Yeah.
And the Llama 4 model, especially Scout, stand out for those absolutely massive context windows, plus strong performance across the board.
That's an excellent summary. It really underscores that, there isn't one best model for everything. Each is kind of optimized differently.
Which, yeah, that leads us right into the next point, the
Yeah.
specific strengths and weaknesses. It's becoming super clear that picking the right model really depends on what you want to do with it.
Exactly right. Like if your app needs that smooth, real-time back and forth across different media, voice, vision, text, GPT-4o looks really compelling.
Okay.
But if your main goal is generating creative content or maybe analyzing huge data sets to find subtle patterns, then GPT 4.5's broad knowledge and pattern spotting skills might be the edge you need. And like we said, for chewing through massive amounts of text or code where keeping track of everything is vital, Gemini 2.5 Pro and the Llama models, especially Scout with that 10 million window, they're just built for that kind of heavy lifting.
What about the downsides, the weaknesses? The report mentioned the potentially high cost for GPT 4.5, right? That could limit who uses it.
That's a huge practical consideration,
Yeah.
absolutely. Cost is always going to be a factor.
Yeah.
For Gemini Ultra, its context window, while decent, is smaller than its newer sibling, 2.5 Pro. So that could be a limitation if you really need that massive context.
Right.
And the Llama 4 models have slightly earlier knowledge cutoff dates mentioned in the report, which might matter if you need the absolute bleeding edge up-to-the-minute information.
So it's really not a case of one model just being flat out better than all the others across the board.
Not at all. It's way more nuanced. The best choice really hinges on the specific job, your budget, how fast you need it, whether you need multimodality if you're dealing with super long texts. All those factors weigh in.
Okay, so those are the big, powerful, general-purpose LLMs. But the report also digs into specialized AI models, the ones designed for specific business uses. What's the main idea behind these? Why build a specialized one?
So these are AI models that are deliberately trained to be experts in a particular industry or domain.
Like finance or medicine?
Exactly. By focusing on the specific language, the context, the unique problems of a field like finance or medicine or law, they can often deliver much better accuracy, efficiency, and just overall relevance compared to a general model trying to do the same thing.
The report gives examples like Bloomberg GPT for finance, MedPol M2 for healthcare, chat law for legal stuff. How do they get that better accuracy, just more focused training data?
Pretty much, yeah. They're trained on huge amounts of data specific to that industry. This lets them build a really deep understanding of the jargon, the subtle meanings, the common problems and workflows within that field.
Okay.
So they can give much more on-point answers for things like, say, analyzing complex legal documents or assisting with medical diagnoses or understanding financial reports.
That makes total sense. It's like having an AI that actually speaks fluent doctor or lawyer.
Exactly.
The report also brings up agent systems. What are these and how are businesses using them? They sound a bit more active than just generating text.
They definitely are more active. Agent systems are kind of the next step. They're AI programs that don't just respond. They can actually interact with their environment, go out and gather information autonomously, and work towards achieving goals you set for them.
Eek.
Think of like really advanced customer service chatbots that can actually fully resolve your issue, not just answer basic questions, or recommendation systems that learn what you like and proactively suggest things. Even autonomous vehicles are a type of agent system.
And for businesses managing tasks and to-do lists, these agents could be really helpful there.
Absolutely. They've got huge potential for automated repetitive stuff, boosting productivity by managing schedules, sending reminders. They can adapt to how individual users work, and even break down big, complex projects into smaller, manageable steps. Some can even control devices or interact with other software.
The report then mentions specific task planning models, AdaptT and TPTU. These sound like they're designed for the really tricky multi-step problems.
They are. Models like AdaptT, that stands for As-Needed Decomposition and Planning for complex tasks, and TPTU, task planning and tool usage. They're engineered for those complex jobs that need not just understanding, but actual strategic planning and using external tools.
So AdaptT can break down a big task if the AI gets stuck.
Yeah, it can recursively decompose a task into smaller bits if the main LLM can't figure it out directly. It's pretty clever.
And TPTU. That seems more focused on how AI agents plan and use tools in a real company setting where you have lots of different software systems.
Exactly. The report mentions TPTU v2, which has components like an API retriever to find the right software interface, an LLM fine-tuner, and a demo selector. It's all about tackling the practical, messy reality of getting AI agents to work effectively with all the different tools and services inside a big organization.
Okay.
These frameworks are really pushing what AI systems can do autonomously within a business.
This all sounds incredibly powerful, but it brings up a big question. Should a company even consider training its own specialized AI models? The report goes into the feasibility, the costs. What are the big things a company needs to think about there?
It's a major strategic decision, yeah. You really have to weigh the potential benefits against some pretty significant costs and challenges.
Let's start with data. The report says you need huge amounts of domain-specific data. Is that easy to get?
Not usually, no. Getting and then preparing the right quality and quantity of data can be a massive hurdle. It's often time-consuming and can be really expensive.
That quality matters a lot.
Hugely. Garbage in, garbage out, right. The data quality directly impacts how well the final model performs. Companies also have to choose. Do they try to train a model totally from scratch using just their data? Or is it better to take an existing big model and just fine-tune it with their specific data?
Fine-tuning sounds easier.
It often is, and techniques like transfer learning or retrieval augmented generation, RI, can make that fine-tuning process much more effective.
And then there's the hardware. Training these things takes serious computing power, right? GPUs, TPUs.
Yeah, absolutely. Serious power. The number and type of GPUs or TPUs you need depends on how complex your model is and how much data you have. It can mean a massive investment in your own hardware, or, more commonly these days, using scalable computing resources from cloud providers.
Which brings up that classic cloud versus on-premise decision. Yeah. What are the trade-offs for AI training?
Well, cloud gives you that scalability and flexibility. You can spin up resources when you need them without buying tons of servers up front.
Right.
On the other hand, doing it on-premise gives you more direct control over your data, potentially better security depending on your setup, but it means big initial costs and ongoing maintenance headaches. Hybrid approaches are also pretty common, using a mix of both. The report even mentions things like Azure's provisioned throughput units, PTUs, as a way to sort of reserve and manage cloud compute power specifically for AI jobs.
So ballpark, what kind of budget are we talking about to train a specialized model? The report says it varies a lot.
It really does vary wildly. You could be looking at relatively modest amounts for smaller, simpler models on focused data, all the way up to millions, potentially tens of millions of dollars for training really large state-of-the-art models on massive data sets. It just depends on the scale and complexity.
Okay, so given all the data challenges, the hardware costs, the complexity, when does it actually make sense for a company to go down the route of training its own model?
The report lays out a few key scenarios. It might make sense if you need a highly specialized model for unique data or tasks that off-the-shelf models just can't handle well.
Okay.
Or if you find existing commercial models just aren't accurate enough or don't understand the nuances of your specific industry.
Right.
Maybe if you think having your own proprietary AI gives you a really significant, lasting competitive advantage.
Mm-hmm.
Or if you have super strict security or compliance needs that basically force you to keep everything in-house.
Got it.
And finally, maybe if you calculate that the long-term cost of constantly paying for API calls to a commercial model for your specific high-volume use case would actually end up being more expensive than building and running your own.
That's a complex calculation, I bet.
It definitely is. Lots to weigh up.
Okay, so building your own model from scratch is one thing, but what if a company just wants a local setup? To run or experiment with different AI tools, maybe mix and match commercial and open source stuff. The report has some recommendations for that kind of local infrastructure too, right?
It does. Yeah, for organizations wanting some AI capability right there on site, the focus shifts a bit. It's about getting the right mix of hardware components, but also really thinking about security, keeping latency low, and managing costs.
It mentions GPUs, CPUs, and NPUs. Can you quickly break down what each does in a local AI setup?
Sure. GPUs, graphics processing units, we've talked about them. They're the powerhouses for speeding up AI calculations. Essential for serious training and often for running the models efficiently, which is called inference.
Right.
CPUs, central processing units, they still handle all the general computing tasks and can do some parts of AI processing too.
Okay.
NPUs, neural processing units, are newer. They're specialized chips designed specifically to run the math behind neural networks really efficiently, especially using less power. You see them a lot in smartphones or edge devices.
And the devices.
Yeah, like small computers deployed out in the field, not in the data center. The report specifically points to the NVIDIA RTX 4080 as a good example of a powerful GPU for a local AI workstation that can handle pretty demanding tasks.
And what about using even smaller setups? Like, could you use a Raspberry Pi for AI?
You absolutely can. Devices like the Raspberry Pi are great for experimenting with what's called edge AI
Okay.
and for quickly prototyping AI features in situations where you don't have much power or space. That's where NPUs really shine. They can give you decent AI performance on those small devices without draining the battery.
So, when putting together this local infrastructure, how do you prioritize? Is it security first, speed, meaning low latency, or just keeping the cost down? How do you balance those?
It's always a balancing act,
Yeah.
right? Depends on the company's specific needs.
Yeah.
On-premise setups can offer more direct control over data security. Running things locally, especially on edge devices, can drastically cut down latency compared to sending data back and forth to the cloud.
Mm-hmm.
But then you have the upfront hardware cost versus ongoing cloud subscription costs. The report interestingly notes that smaller, efficient models, like that GPT-4o Mini,
Mm-hmm.
could help lower the running costs of local AI too.
Right.
So ultimately, a good local setup might mix powerful GPUs for the heavy lifting, regular CPUs, and maybe some NPUs for specific on-device tasks, all chosen based on that balance of security, speed, and cost needs.
Now, a really critical topic when you're dealing with AI, especially these LLMs, is privacy, protecting personal data. The report talks about open source tools for anonymizing data before you send it to an LLM. Why is that step so important?
Oh, it's absolutely crucial. Anonymization is vital for protecting people's privacy and for complying with data protection laws like GDPR.
Right.
Just feeding raw personal information into an LLM without cleaning it first, that carries huge risks.
The report lists a few open source frameworks: Microsoft Presidio, Elara, LLM Anonymizer, TextWash. What do these tools generally do?
Their main job is to find and then remove or replace personally identifiable information PII from data, especially text data.
Like names, addresses.
Exactly. Names, addresses, phone numbers, social security numbers, that kind of thing.
Yeah.
They use different techniques to essentially de-identify the data
Yeah.
while hopefully still keeping it useful for whatever analysis you want to do.
And how do you figure out which one is any good? Are they all the same? What should you look for when evaluating them?
No, they're definitely not all the same.
Yeah.
How well they work really depends on your specific needs and how complex your data is.
Okay.
Key things to look at are, what types of data can it handle? Just text or images too. What anonymization techniques does it offer? Like just blacking things out, masking, replacing them with fake data, tokenization, making them less specific, generalization.
Mm-hmm.
How well does it preserve the actual usefulness of the data after anonymizing it? Is it easy to use and plug into your existing systems? Can it handle large amounts of data efficiently? And is there good community support and ongoing development? You really need to check them against your specific situation.
Makes sense. Shifting gears a bit, the report also outlines some key topics and skills that developers working in AI really need today. What are some of the big ones they should be focusing on?
Yeah, there are definitely some core areas that are becoming essential for developers in this space.
Let's go through a few. First up, prompt engineering. We hear that term constantly now. What's the basic skill there?
Prompt engineering is basically the art and science of writing really good prompts, the instructions you give to the LLM to get the best possible response back.
Okay.
It means understanding how these models think, how they interpret language, and how to guide them effectively with clear instructions and the right context. It's trickier than it sounds.
I bet. Next is retrieval augmented generation, RG. What's that all about?
RG is a really important technique. It helps make LLM answers more accurate and up-to-date by connecting the LLM to external knowledge sources.
How does that work?
Before the LLM generates an answer, the RI system first searches a database or a collection of documents for relevant information related to the prompt.
Oh,
Then it feeds that retrieved information along with the original prompt to the LLM. This helps the model base its answer on specific current facts, especially for stuff it wasn't trained on.
got it. Then there are LLM agents. We talked about these for business use, but what's the developer angle when building them?
For developers, building LLM agents is about designing those autonomous systems. It's about creating the logic that lets the LLM not just answer questions, but actually plan tasks, use other tools or APIs, and make decisions to reach a goal. It's complex programming.
Right. Height and compliance, security and compliance, obviously critical.
Absolutely non-negotiable. Developers need to understand the security risks, things like prompt injection attacks, data leaks, and also be aware of potential biases in the models.
Right.
And they need to know how to build in safeguards and make sure everything complies with data privacy laws and ethical guidelines.
The report mentions something called vibe coding, linked to vibe evil for images. That sounds subjective. What's that about?
Yeah, vibe coding seems like a newer idea. It sounds like it's about evaluating the more aesthetic or sort of the perceived quality aspects of what an AI generates, going beyond just whether it's factually correct.
Okay.
The mention of vibe eval for images suggests it's about assessing the overall feel or, well, vibe of an AI-generated picture. It points to the growing importance of user experience and those more subjective qualities, especially in creative applications.
Interesting. And finally, data management. Seems pretty fundamental for AI.
Totally fundamental. It covers everything from collecting and storing data to cleaning it, processing it, ensuring its quality, and setting up rules for how it's governed. You can't build good AI without good data management.
Okay, looking ahead now, the report talks about future developments. What are some of the big trends we should be watching out for?
Well, the report basically says, expect more of the same rapid progress in generative AI through 2025.
Faster, better, stronger.
Pretty much. Better model capabilities, better efficiency, AI getting used in even more places, more innovation in multimodality, even bigger context windows, and probably more of those specialized models we talked about.
And that trend of Agentifizierung, agents becoming more common.
Yeah, generative, that increasing focus on building AI systems that can act autonomously, make decisions, complete tasks on their own, that's expected to really broaden what AI can do.
The report also briefly mentions new hardware like digits and Gaia. What should we take away from that?
It doesn't give details on digits or Gaia specifically, but the general point is that new specialized hardware is still super important for pushing AI performance and efficiency. We can probably expect more hardware innovations designed just for AI that will give us big speedups.
And supercomputers are still key.
Still absolutely critical, yeah. Especially for training those massive foundation models like GPT 4.5 or the Llama models. You just need that enormous computing power to push the boundaries.
And lastly, open source ecosystems are growing. Why is that important?
The growth in open source AI models, tools, frameworks being freely available is a really big deal. It makes AI development more accessible to everyone, not just giant companies.
Democratizing AI.
Exactly. It lowers the barrier to entry, encourages more collaboration, and generally speeds up innovation because people can share and build on each other's work.
Okay, so given this incredible speed of development, new models popping up constantly, the report asks a really critical question. Is it even worth it anymore for companies to try and develop their own AI models from scratch?
It's a really tough question right now, yeah.
Yeah.
With such powerful commercial models readily available, often just an API call away, the case for spending millions on in-house development needs to be incredibly strong.
So what does the report suggest? When might it still make sense?
Pretty much aligns with what we said earlier. Maybe if you have truly unique needs that no existing model can meet,
Right.
or if you have exclusive data that gives you a massive competitive advantage if you build a model around it, or if that proprietary AI capability itself is your core business advantage. But you absolutely have to do that cost-benefit analysis. Compare the huge costs of data, hardware, specialized staff against just using or fine-tuning commercial models.
Yeah.
And you have to factor in the challenge of just keeping up with how fast the commercial ones are improving.
So the bottom line seems to lean towards, in many cases, maybe most cases, using and adapting existing commercial models is probably the smarter, faster, cheaper way to go.
That's often the most pragmatic conclusion these days, yes. It allows you to leverage the billions being invested by the big players.
Okay, so with this huge menu of models and tools out there now, which ones are generally best for what today? Based on everything we've discussed, does the report give some rough guidance?
It does offer some general pointers based on those strengths we identified. For that real-time, multimodal stuff interacting via voice, video, text, seamlessly, GPT-4o seems like the go-to right now.
Okay.
If you need that absolutely enormous context window, like for analyzing incredibly long documents or massive code bases, Llama 4 Scout is the standout.
Right, the 10 million token one.
Yep. For tasks needing top-tier reasoning, complex programming, and a very large context window, Gemini 2.5 Pro is a strong contender. For more general content creation, broad knowledge questions, maybe GPT 4.5 or Gemini Ultra are good choices.
Got it.
And for those specific business process things, task planning, workflow management, you might look into specialized agent systems or those task planning models like Adaptee or TBTU.
And there were some prompt management tools mentioned.
Yeah, Prompted and 16x Prompt were mentioned as potentially helpful for managing prompts, especially with models like GPT-4o.
But the key message is still, it really depends on your specific use case. Right?
Exactly. Always comes back to what problem are you trying to solve? Then you evaluate the options based on cost, performance, usability, specific features.
Now, AI agents. Lots of buzz, but also some nervousness. The report asks, are they actually ready for prime time? Isn't using them potentially dangerous? How can we use them safely?
Yeah, AI agents are definitely developing fast and getting used more. But are they fully mature and ready for all business applications? Probably not quite yet. Their capabilities are still evolving.
And the safety concerns? Are those real?
They are legitimate concerns, yes. There are definitely risks. Security vulnerabilities, the potential for them to do unexpected or harmful things. It's not science fiction.
So you need to be careful.
Absolutely. You need careful risk assessment, robust mitigation strategies, things like strong access controls, continuous monitoring of what the agents are doing, and really thinking through the ethical side before you deploy them.
What are some best practices for using them more safely?
The report highlights things like clearly define the agent's goals and boundaries, what it can and can't do. Always have human oversight, especially for critical decisions. Don't just let the agent run wild with important stuff.
Right.
Conduct regular security checks on the agent systems. And make sure they're trained on high-quality, unbiased data and have ways to detect and reduce bias in their actions.
Okay. The report also had some very specific hardware questions. What's the best AI model you can run on an NVIDIA RTX 4080? And what's best for a little Raspberry Pi?
Yeah, determining the absolute best model for a specific card like the RTX 4080 that needs really detailed, specific benchmarks that weren't in this report.
Yeah.
But generally speaking, the RTX 4080 has a good amount of VRAM, video memory, so it can handle running many modern LLMs, especially if they're optimized for inference, for actually using the model rather than training it. Smaller versions of Llama, Mistral, or maybe fine-tuned larger models would likely run well.
And for the Raspberry Pi, which has way fewer resources.
For a Pi, you're looking at really lightweight, highly optimized models, things like TinyBird or specific models designed just for edge devices. Performance will really depend on which Pi model you have and how well the AI model is squeezed down.
Okay. Finally, the report mentioned a new feature, GPT-4o with scheduled tasks. What's that?
Right. This is a new beta feature for GPT-4o. It lets you set up prompts to run automatically on a schedule.
Like run this prompt every morning at 8 a.m.
Exactly. You give it a prompt, maybe summarize the top tech news, or give me a French vocabulary word to practice, or just remind me to call mom and set a time. The system runs it and notifying you.
How does it notify you?
Push notification on your phone or email. You can set up to 10 of these active tasks currently.
It works everywhere.
Available on the web, iOS, Android, macOS apps. But the report notes it doesn't currently support things like voice chats, uploading files, or using custom GPTs within those scheduled tasks.
So it's basically like setting up recurring automated check-ins or information pulls from the AI.
Pretty much. The idea is to automate those routine, predictable things, simplify your daily workflow a bit.
Any hints about where it might go next?
The report suggests future updates could include things like the AI recommending tasks you might want to schedule, integrating with other apps, maybe even adapting tasks based on your feedback. It's kind of positioning it as a step towards a more proactive, helpful AI assistant.
Okay, wow. We have covered a ton of ground in this deep dive into the current AI landscape. If you had to boil it down, what's the single most crucial takeaway for our listener from all this?
I think the biggest takeaway is just the sheer speed of evolution here. AI, especially LLMs, is moving incredibly fast. We're seeing these increasingly powerful models with really diverse capabilities popping up constantly, from understanding multiple senses to remembering vast amounts of context to specializing in very specific jobs.
And the key to actually navigating this then is really understanding your own specific needs and priorities before jumping on the latest shiny object.
Precisely. Know what problem you're trying to solve. And alongside that, as this field keeps charging ahead, skills like prompt engineering, understanding RGAN, and just having a solid grasp of AI safety and ethics, those are only going to become more vital.
Right. So as we wrap up this deep dive, here's maybe a final thought to chew on. Given this extraordinary pace of development, these constantly expanding capabilities, what applications that seem like science fiction today might actually become commonplace really soon?
Good question.
And what are the deeper implications for how we work, how we live? It's definitely a lot to think about, that balance between harnessing these amazing tools and carefully navigating the risks and the ethical questions they raise.
Absolutely.
Thanks for joining us for this deep dive.